Hey, I will talk about closures in this video, which I think is very important and useful feature in JavaScript. So if you look to the MDN page, which I think if you want to learn JavaScript or any concept, you should at least start by reading this page for any concept. So a closure is the combination of a function bundled together enclosed with references to its surrounding state, the lexical environment. In other words, a closure gives you an access to the in other words, a closure gives you access to an outer function's scope from an inner function. In JavaScript, closures are created every time a function is created at function creation time. So I think if you look at this simple example, things would be more clear. So as you can see, they are defining this init function, and they are defining or declaring this variable called name, and here they are defining the display name function. And this display name function have an access to this name variable, so it can access that variable at any time. And even if you returned from this init function, it will still be able to access that variable. So it will be, you can say, preserved in the memory for this function. I will show you an example for that. So let me go to VS Code. So this is just the HTML I will be working on. This is just some styles. You don't need to write these. So just a H1 with this ID and the button with this ID. So the two useful features, I think there's a lot, but the things that I like to use is caching with closures, and the other thing is creating a private state and enclosing data or encapsulating data for functions. And I'll show you two examples or three for these. So first thing to make, since I added IDs to these, I'll be using document.get element by ID. So instead of keeping writing that, I will just assign it to a function called get by ID, which will just accept an ID and just return an element with that ID, just to stop repeating myself a lot. And now the first example, I will just update this text every second with a random number between 0 and 10 or 0 and 9. So there is this function called setInterval in JavaScript. It accepts a function, which, by the way, when we pass as an argument a function to another function, like this case, we will call it a callback function. So this is a callback function, okay? And each second, which is the second argument, each 1 second, this function will be called, and I will make it update this text. So the way to do it, we will grab this ID and pass it here, and now dot inner text or inner HTML, I will just use inner text. It will be equal to math dot floor and pass to it math dot random times 10. So let me go now to the browser. So as you can see, each time this number will be updated, but we can improve this. Let's say, for example, selecting this element will be a complex thing to do. We can just cache the element returned from the get element by ID function. We can cache it using closure, and I'll show an example, and I will keep simplifying that to just pass it directly to the set interval. But before this, I will just create a function called update h1. It won't accept anything, and it will return at the end just a function. Now to cache some things, we will define here a couple of variables. First one is the h1, which will be equal to get by ID, and pass it the display number. Another thing we can also cache, it's not useful, but we can do this. From the math object, get the floor function and get the random function, and assign them to a variable called floor and a variable called random. This is called destructuring, and it's really useful. I like doing this a lot. So now what I will do, I'll just return this function which updates the h1 with floor, now random times 10. And let me remove all of this and call update h1. So, and now let's go back to the browser. This should give us the same behavior. So each time this will be updated from number from 0 to 9. The difference between this and the previous example is we are calling this get by ID once we are selecting or retrieving this element from the DOM only one time, and for each second we are updating the text. I can actually prove this to you if I console log here. So this will happen only one time. Yeah, sorry, I need to return. So this will happen only one time. In the previous example, it will happen each second. So this is a way to cache things. And this function, which will be executed each second, will have an access to the h1 and the floor and the random function, even though this function executed the return statement. This is what, this is how we can cache things in closures. Yeah. So another thing, which I think it's this thing, just cut this and remove this. So you can put parentheses here and put your code, and then as you can see, all of this function is enclosed with this parentheses, which makes it an expression like this. Now we can invoke that expression, and I will put inside it that function, and this will still work fine, as you can see. And this is called an IFE, like this, F-I-F-F-E, which stands for immediately invoked function expression. So sorry, IIFE, immediately invoked function expressions, which I usually use them when I want to put something in really small place without just defining another variable. So this is a use case for that. You can read about it. It's called IFE. So basically, you're just declaring a function and invoking it, which could be called a function expression. So another thing we can implement, which I will just go really fast about it. I want to implement a double click feature for this button. So to do this, I'll just get by ID. I will get this button. I'll show you how we can, in this example, create a private state for functions, so they can use to compare the previous state with the current state, and based off that, do something with the DOM. So add event listener, click. Now this will be, and let me just define a function here. Let's do it like the previous one. So const click me to. This will be just a function that will return another function. So the state or the things that I will define that the closure will have access to, or you can say the function here, sorry, the function will have access to these, and all of this will be called a closure. Which, by the way, in interviews, when they ask me what are closures, I will just say a function with its lexical scope. That's it. That's how I usually answer that, and they usually accept that. So the first variable is first click time will be null. This is the time where the first click happened. Now the counter will be equal to 0. This is how many times this button got clicked, and each time this function here will be executed on the click event on this button. These two will preserve the previous state. Now I will just compare a couple of things. If they are true, I will apply the toggle, the large class. I will toggle that. So it will just give a cool feature to the button each 2 times we click it, or yeah, for each 2 times we click it, for 2 clicks. Anyway, so first thing, this will accept the event. This is the normal DOM event on the click. Now counter plus plus, which means we click it. Now if the first click time is null or falsy, it's null. I'll just assign it to date.now. So this is when this function got clicked the first time. Now I will prevent the default behavior from this function and just return to stop the execution of this function. I think we don't need this, but this is how we show you how you can prevent the default behavior of functions or events. Sorry, yeah, events. This is how you can stop function at any time. Now, if that is false or if that did not fire, I'll just create a variable called time will be equal to date.now. This is when the function got clicked, the new time, and this is the previous time, the first click. This is the second click, and I will create a def time. This will be equal to time minus first click time over 1000 to convert it to seconds. Now if def time is less than or equal a second, which is 1, and counter is bigger than or equal to 2, I will just I will just get this element again, which is the closure button, which thinking about it, I should define it in a variable, so const button like this, and I will put it here, and also button dot class list dot toggle large, which is each time this event will this if statement will resolve to true, and this block will be executed. I'll just add or remove this class, just toggle it basically, and now I'll just return the counter to 0. At the end, no matter what happened, I will just assign the current date to the first click value. So to make the next time the function get called, will have access to the previous time the button got clicked. So this is how I'm preserving the previous state each time. I think that's it. Now I need just to code it here, and that should be it. Let's go to the browser and look at that. 1 second. So as you can see, when I click 2 times, this will be activated, and if I clicked only 1 time and stopped, then 1 time nothing will happen. It should be 2 clicks or more in less than a second. So we can actually console log the difference time. So that's why I saved them in variables. So let me just copy paste something. This is we'll just log out the time different. Let's go and check it. So this is the different time between the 2 clicks. That's why this got activated. This is 0.9, which is still less than a second. So yeah, I think this is really a cool feature, or a good example in using closures to create a private state and closing data. So yeah, and by the way, how I get this text here in the console, if you passed this %C, now you can apply the normal DOM styles here. So as you can see, I'm using text shadow, font size, color. You can Google that. I think just Google how to apply styles in the terminal in the Chrome developer tools. I think this also works in Firefox. And the final example, I will show you how we can cache things, and precisely a way of caching which is called memoization without the R. Yes. So I will use the Fibonacci number examples. So I will create a function called fib, which first thing defines a cache variable. I'm not sure if I wrote that correctly. I think yeah, it's like this. So this is just an object. We know that for 0 the value is 0, for 1 the value is 1. So this is the initial state of the caching. Now I'll just return, and this is something interesting. I think we can name functions in JavaScript. Obviously, but we can name the returned function in JavaScript. So you can just like this. This will be called f, but I want to use an arrow function, which you can do it like this. Hold on 1 second. And I think Prettier will add these parentheses, but you don't need them. But yeah, I will call this function counting function, like this. And this will accept that Fibonacci number you want to get. So what I will do, if this number in cache, which means we have it, I will console log that we already have this number, so we won't compute it, and I will just return it from the cache. Now, if this did not fire, I will just assign in the cache this value by the key. Sorry, not this value. I will assign in the cache by this key, which is the current number we are trying to get, the return value from counting fun to n-1, and pass to it the cache. So you don't need to pass the cache. You have an access to the cache. Plus counting func n-2, and these actually have an access to this, since this is part of the closure that got created for this function. And now just return cache of n, and that's it. Now to call this or to read this, first thing you need to call I will call it initfib. Just call this function. This will init the state, which is the cache, for this function. Now, so console log initfib 2, and let's go to the console. Hopefully no errors. So as you can see, from cache we got 1 and 0. Because they are already cached, and now we got the final number, which is the sum from these two, which is 1. I hope you can see this. 1. Now if we go to 3, we should see that 0 and 1 and 2 is cached. So 0 and 1 and 2 is cached. This time for 1, for the value 1, which is 2, the Fibonacci number 2 is 1, and for Fibonacci number 3, these two are cached, and this is the value. Okay. Now I think it's 2, so let me show you these examples. So from 4, 5, 6, 7, you should see that we will return a couple of times from the cache, and we won't compute anything. So as you can see, so the 7th number in Fibonacci is 13. I mean, the calculation is right. The 6th number is 8. Yeah. So I hope this is useful in any way, or at least it will get you excited to Google some stuff. I think that's it. Maybe I will put this code in a repo, or at least in a guest. You can check it. So yeah, I think that's it.